This video will be on section 9.1, polynomial functions and inequalities. So we'll start by looking at what the definition of a polynomial is and a few things that are important about it. Then we'll look at the intercepts and zeros of a polynomial. This is something that you'll see when we get there. You could have done this before, but always good to practice extra. And then the last part is solving polynomial inequalities. And what I'll say about that is if you remember doing the absolute value inequalities, it's pretty much the same thing when you find where the polynomial inequality equals 0 and plugs in a whole bunch of numbers on the number line. So if you learned it that way, this solving polynomial inequalities is really no different. If you use a different way for the absolute value inequalities, this will feel very new. So just be aware of that. All right, so the first thing is the definition and some important things about a polynomial. So a polynomial function, f, is a function that can be written of this form. Now I have a lot of things to really explain what this means, but it says f of x equals a subscript n times x to the n power plus a subscript n minus 1 times x to the n minus 1 power. And what happens is you can have a whole bunch of these terms added together. And we're just kind of descending in the exponent. So the exponent goes down to n minus 2. Imagine if n was 10, then this would be x to the 10th, x to the 9th, x to the 8th, so on, down to x to the second power, x to the first power, and then no x at all, x to the 0 power. The a's here are called coefficients, and they're just real numbers. All right, so really what a polynomial is, this is what I recommend remembering, but we'll work a couple examples just so you can see what is and what is not a polynomial. So each term is a number. I should write a real number times x raised to a power. Now, specifically, the powers of x are positive whole numbers, positive integers. You cannot have negative exponents, you cannot have radicals, you cannot have fractions in exponents, and if you do have a fraction, your x can't be in the denominator. You can have numbers in the denominator, but not x. Right, like I said, we'll see an example very quickly of what a polynomial looks like, but you're very familiar with them. You just probably may have never called them by their name. All right, so each of the a's, meaning the an minus 1, and so on, are called coefficients. And they're just real numbers. So, like 2x, the 2 would be the coefficient there, the x would be the power. Now, the three special things about a polynomial that aren't so important in this class, but are more important when you study polynomials in future classes. You have the degree of the polynomial, which is just the largest exponent of x. You have the leading coefficient of a polynomial, which is the number multiplying the largest power of x. And finally, you have the constant term, which is the number by itself. All right, so in this problem, in the formal definition up here, the constant term is just the a0, but what you're looking for is something without an x. All right, so for each of the following functions, determine if it is a polynomial. If it is, state the degree, leading coefficient, and constant term. All right, so the first question is this a polynomial? Well, really what we're looking for is every term a number times x raised to a positive whole number power. Or without an x. We can also have just a number. Because let's say polynomial is every term a number times x to a positive whole number power, or just a number. And you get pretty quick at this. This is yes because really you pay attention to the powers of x mostly. All the powers are good. X cubed, x to the 6th, x to the 1. They're all positive whole numbers. They're all being multiplied by just numbers. 3, -2, and 1/2. It doesn't matter if these are fractions or whole numbers, positive or negative. Doesn't matter for the numbers, just the powers of x. And then the last thing here, then -1 is just a number. So this is a polynomial. Quadratic functions and linear functions are polynomials. All right, so the 3 questions, now that we do have a polynomial, what is the degree? Well, the degree is the largest exponent of x. So you see here the largest exponent of x is 6. What you don't want to do is look at the front and assume it's in the front. Sometimes it is, sometimes it isn't. So you have to look through all of them. The leading coefficient well, this is the number multiplying the largest power of x. It's not the number in front. The number multiplying the largest power of x. Don't forget the negative. If you have a minus, it's -2. And then the last thing, the constant term. The constant term, we do have a number by itself without an x. It's -1, and that's what the constant term is. It's the number by itself. Right. If you have a polynomial, you always have these 3 things. None of these are ever going to be D and E if you have a polynomial. Right. One thing I will add, because this example didn't have it, if there is no term with just a number, so it looks like there's no constant term, then the constant term, it's really there. It's just like having a +0 at the end. Right. So that can happen. If this -1 wasn't here, visually, if it was gone, so we just had these first 3 things, we wouldn't say the constant term is D and E. We would just think about it being a +0 at the end, because really there is a 0 there. We just would never write it in. All right, so number 2 here, before we worry about trying to answer the questions, what is the degree, leading coefficient, constant term, we want to know, is this a polynomial? And the answer to this one, I can actually tell right in the front, it is no. This is a bad term. Why is this a bad term? You can't have x's in the denominator for a polynomial. It doesn't matter if it's a positive whole number power, it's not allowed to be in the denominator. And if you remember some exponent rules, you'll actually know that this is actually a negative exponent in disguise. So 3 over x to the 7th equals 3 times x to the -7. If you bring up something from the denominator to the numerator, or bring it from the numerator back down to the denominator, it makes the exponent have an opposite sign. So this is actually a hidden negative exponent. Either one of these, the way it's written, it would be bad. So moving, I don't want to say flipping because we're not flipping the fraction, but moving from top and the bottom in a fraction changes the sign of the exponent. And I really don't even think we've said that once in this class. It is an old exponent rule. That's a prerequisite, but if you don't remember it, there's a reminder. And then the last one here that I have, is this a polynomial? Because once again, none of these questions make sense. Degree, leading coefficient, constant term, unless you have a polynomial. And if you go through, the first two terms are fine, the last two terms are fine, but you cannot have a radical. Right, all the exponents have to be positive whole numbers. We saw in the previous one before that having an exponent in the denominator is really like having a negative exponent. The reason you can't have a radical, because it's a hidden fraction exponent. I'll remind you of that rule as well, that exponent rule as well. So 14 times the square root of x. The 14 is not really important for explaining this, but the square root of x right, this is the same as what? Well, really, there's an invisible 2 here, right? When we don't write a number on radical, it's an invisible 2. And then when we don't write a power on the inside, it's because it's an invisible 1. And your exponent rule tells you if you want to switch from radical to exponent, your exponent becomes a fraction. The exponent inside is the numerator, the exponent on the outside is the denominator. Right? And as you can see, that is a fractional exponent. It's not a whole number, so it's bad. Right, so once again, if this thing was gone here, then the rest would be a polynomial. Same thing for the above. If this one was gone, then this would be a polynomial. And then we saw an example of one that is a polynomial. Right, so the intercepts and zeros of a polynomial. This stuff here is just a reminder, but really you have learned all this before. The intercepts and zeros of a polynomial are a question we have answered before when the polynomials were linear, which is degree 1, or quadratic, which is degree 2, meaning the highest powers were of x was 1 or 2. Right? So to find the y-intercept, it's not unique to polynomials, sometimes called the vertical intercept in the homework. We know what we do is we set the input variable x equal to 0 and get the y, and our y-intercept is written in the form 0, comma, y, whatever number we get out. Right, so we get a y-intercept, we plug in x equals 0. To get the x-intercept, what do we normally do? We plug in y equals 0. But usually we don't have y equals, we have a function name, so we replace the function name with 0 and solve for x. And we know our x-intercepts are written in the form x equals 0. And then the last one, the zeros, we've talked about x-intercepts and zeros before. X-intercepts and zeros are pretty much the same thing, but the zeros are just the x value. It's not the ordered pair of the x-intercept. All right, so what we'll do is I just have a couple examples here to remind everyone and practice this, but also, kind of talk about this first form. So this first one says find the zeros, vertical intercept, and horizontal intercepts of the following functions. If there are none, write D and E. All right, so I always just like to do the zeros and x-intercepts first because they go together. So I'll do the zeros first. Oops. Let me use the same color I had. So we know to find the zeros or the x-intercept, we replace the f of x with 0. And now one thing to notice here is this is already factored. You don't want to unfactor anything ever. This is already factored. What I would do here, since the thing out front, it doesn't have an x in it, it's just 4, just divide by 4 and get rid of it. That's my preference. You can leave the 4 there, it won't affect your answer at all, but I just prefer not to have anything in front if there's no x's. So what do we do if something's already factored and set equal to 0? Well, then we set each part equal to 0. We got 0 equals the front part, x minus 10 squared. Don't let that squared bother you. We'll see that it doesn't affect much. We have 0 equals the next part, x minus 11, and then 0 equals the last part, x plus 11. All right, now the one on the left, how do you want to solve this? If we solved something like this before, we know we want to get rid of the squared because then we can easily solve for x. We do that with the square root. And we are supposed to do the plus or minus when we do a square root. So the square root and the squared knock each other out, and we just have the inside left. Now, do keep in mind that the square root of 0 is 0. So plus or minus 0 are the same thing. So we don't actually have to keep the plus or minus around anymore. And now we can solve this. We can add 10 to each side. And we get x equals 10. For the middle one and the right one, there's no exponent, so we can just do it right away. Middle one, we add 11 to each side and get x equals 11. And the one on the right, we subtract 11 and get x equals negative 11. Right, and remember, the zeros are just the x values. So these three numbers here are the zeros. 10, 11, and negative 11. The x-intercepts go along exactly with the zeros. These are the x values, and the y value is 0. The zeros are the x value of the x-intercept. So we got 10, 0, we got 11, 0, we got negative 11, 0. And then the y-intercept's the totally separate thing, but it's usually the easiest thing to do. What do we do to get the y-intercept? We plug in x equals 0. So we get f of 0 equals 4 times 0 minus 10 squared, plugging it into the original, times 0 minus 11 times 0 plus 11. This number looks like it's going to be quite big. Here we've got 0 minus 10 is negative 10 squared, which would be 100, times 0 minus 11 is negative 11, times 0 plus 11 is positive 11, And that's pretty big, so I'm going to type that into the calculator. So we've got 4 times 100 times negative 11 times 11 is negative 48,400. I could not imagine trying to actually find that by graphing this because that's a huge number. You have to do it, actually do it like this. In our y-intercept, we get x equals 0 and y is negative 48,400. And those are the answers. Our zeros, our x-intercepts, and our y-intercept. All right, this next one is much the same, except it's not already factored. And it's a factoring technique that you probably haven't used in a while in this class, but you still need to know it. It's a good reminder in this problem. But I'll start exactly the same way. I'm going to find the zeros first. So replace f of x with 0. Got 0 equals 3x cubed plus 8x squared minus 6x minus 16. And this is something that we cannot use the quadratic formula for because we have an x cubed. I know we have that new tool now, but we cannot use it here to solve for x. We cannot use the quadratic formula. Also notice that there's nothing in common to simplify or to factor. So you've hopefully remember one kind of factoring that you use when there are 4 things that cannot be simplified, and that is factor by grouping. Okay. So we can only factor by grouping if there's 4 terms that cannot be simplified at all. So you take the first 2. What's in common with the first 2 here? Only x squared. Then when we take the x squared out, the front term becomes 3x. The back term becomes 8. Now the back 2 terms here, what do we have in common? We have a 2 in common, but we also have a negative sign in common, so I'm going to take out a minus 2. And then when we take out the negative 2 from negative 6, we get positive 3x. And we take out a negative 2 from negative 16, we get positive 8. Now, you'll find if you don't take the negative out here that you'll have to still take it out in the next step. So it's good to just take it out now. And that we still have equals 0 on the left. All right, now we have the insides the same. That's what's important for factoring by grouping. So we factor that out, the common term. And we got 3x plus 8 to factor out. And what's left from the front is x squared. What's left from the back is minus 2. That 0 equals 3x plus 8 times x squared minus 2. Now you can set each factor to 0 and solve it. So we had 0 equals 3x plus 8 and 0 equals x squared minus 2. Solve for x in both of them. On the one on the left, we subtract 8. We got 3x equals negative 8. And then divide by 3. And we get x equals negative 8 over 3. For one of our answers. For the one on the right, since we only have x squared, we can add 2 to each side and then do the square root. So we got x squared equals 2. do the square root of each side. Now this one has a number that's not 0 here, so when you do the plus and minus, you get two different numbers. The squared and the square root knock each other out, and we get x equals plus or minus square root of 2. And we can see here for the zeros we have three answers. We have negative 8 over 3. We have positive square root of 2. We have negative square root of 2. Right, now that we've done the zeros, the x-intercepts part is pretty quick. Just like last time, if we want to find the x-intercepts, we just make the coordinate pair. The x value is the x value of a 0, and the y value is 0 itself. So we got negative 8 over 3 comma 0, square root of 2 comma 0, and negative square root of 2 comma 0. And then finally for the y-intercept, we plug in x equals 0, and we get f of 0 equals, what's going to only remain is this minus 16. If we plug in 0 for each of these x's, it's all going to go away. We get negative 16. So our coordinate pair is 0, comma, negative 16 for the y-intercept. Right, now when it comes to solving the inequalities, which we're about to do, finding the zeros or the x-intercepts are really one of the most important things you can do. We won't necessarily do the y-intercept very much. Right. So there are a lot of tiny steps to solve these inequalities, but I have them outlined in probably more steps than you really need to think about. So the first thing, if you want to solve a polynomial inequality, is this is what's different from the absolute value inequalities, is you have to make one side 0 by adding or subtracting. Never multiply or divide with a variable, only add or subtract. And here's where the similarities really begin. Change the inequality to an equal sign and solve that equation. So we're going to make one side 0, then we're going to solve the equal version. Right, then what do we do next? We put each number from the previous part on a number line. So that's the same as before. We changed it to an equal sign. Then we put those numbers on a number line. Then we plug in numbers into the inequality when one side is 0 into each interval on the number line. So what that means is after this first step, you'll still have an inequality. That's where we're going to plug them in. And there's kind of two ways to record your answers here, either with a plus or a minus sign, whether it's positive or negative. Or since you have an inequality here, you can write a yes or no depending on which one works. Right, then based on your number line, you're going to choose the correct intervals. And the last one is really just a reminder, it's not actually a step. Whether you use brackets or parentheses depends on whether the inequality has an equal part or not. Right, but I'll go through those steps as we work through the couple problems we have. I'm intentionally doing probably what is the hardest one. Most of them just have squared in them, like x squared or whatever your variable is. This one has cubed. So if you can follow along with this one, the other ones will just be shorter. So we first got to make one side 0. And the easiest way to do that is to add y cubed to each side. So we got 0 over here. Don't mess around with the inequality because we only added or subtracted. Then on the right side, we got y cubed minus 17y squared plus 72y. If you don't like the way it's written, just if you prefer the 0 on this side than the variables on the left side, you can flip them. Meaning we got y cubed minus 17y squared plus 72y. Since this is opening towards the number, we'll have less than or equal to 0. That might be easier to read for you, but it's up to you. All right, so what did we do after we made 0? We changed the inequality to an equal sign and solve. We got y cubed minus 17y squared plus 72y equals 0. Right, and now you want to solve this. All right, we already have 0 on one side, so let's just go ahead and factor. Keep in mind, once again, you can't use the quadratic formula here because we have y cubed. We would need just y squared. We do have a common y here to take that out. We got y. We take that out, we got y squared minus 17y plus 72. Oops, close my parentheses, equals 0. And now you can factor this. What two numbers multiply to 72? Positive 72 and add to negative 17? Well, that's negative 8 and negative 9. So we've got our thing factored. Unlike that problem before, we don't divide to get rid of the thing in front because we have a variable there. We have y. We got to leave that as it is. Set each factor to 0 and solve. We got y equals 0, y minus 8 equals 0, and y plus 9, or not plus 9, that's minus, y minus 9 equals 0. Left one is solve for us. Middle one, add 8 to each side just because I'm out of room. I'm not going to visually write that, but we get y equals 8. The one on the right, add 9 to each side, and we get y equals 9. All right, so we solved our equal version. What do we do next? That's when we make a number line, and we're going to plug in or plot the numbers on the number line. All right, so the three numbers here, we got 0, 8, and 9. You don't need to space them out evenly. Give yourself enough room between, just mark those three numbers off. All right, so we have our number line made, and now we want to plug in numbers between each one. All right, so this is why I did the example before like this with the absolute values. That's the only way to do this example. We plug in numbers into the inequality. Now I'm going to plug them into here. Whatever numbers I choose, plug in here. All right, so I got to plug in a number to the left of 0, let's say negative 1. I got to plug in a number between 0 and 8, like 1. I got to plug in a number between 8 and 9, which is a little unlucky because there's no whole number in between. I'll plug in 8.5. But we can use our calculator for this step, so no big deal. And then we can plug in a number bigger than 9 to the right, which is 10. All right, so what we're going to do, just like before, I'm going to plug it into the left side with y cubed minus 17y squared plus 72y. I'm going to plug in these numbers and see what happens. So we'll plug in -1, we get -1 cubed minus 17 times -1 squared plus 72 times -1. And like I said, I'm just going to use my calculator here because all you're doing is plugging in numbers. -1 plus 72 times -1 is -56. And now the question is this less than or equal to 0? Yes. All right, -56 is definitely less than or equal to 0, so I'm going to put a yes over the -1. And remember, what we do is we plug in all these numbers. For each number, we're going to put a yes or a no. You could also write if it's positive or negative. And then, since we want negative, less than or equal to 0, you could pick the negative ones as well. We're going to plug in 1. We get 1 cubed minus 17 times 1 squared plus 72 times 1. The advantage of having a calculator when you plug it in, aside from not having to do this by hand, is you can just second enter to copy what you plugged in and then just fix the numbers. That's what we get when we plug in 1. It's 56. Is that less than or equal to 0? And the answer is no. So 1 gets a no. And then do the same thing for 8.5 and 10. So, oops, 8.5, when we plug that in, this is really where you want to have a calculator. We get 8.5 cubed minus 17 times 8.5 squared plus 72 times 8.5. And what does that equal? Now this you're going to want to hit insert because there's more than one digit. 8.5. If you hit insert, then it just puts it in front. We got 8.5, and then I'm going to delete that one. And then same thing here. 8.5. Delete that one. And we get 1081.625. All right, so I just realized that when I was plugging in these numbers that I forgot the squared on these. So I'm going to just redo that in the calculator real quick. If you picked up on that, you would probably see that you got different numbers there. But I redid the 8.5 with the squared first here, and we got -2.125. And it's -2.125 less than or equal to 0. This one is a yes. So I know that one's right because I fixed that one. Let's go ahead and redo 1 and -1 though. So I don't know if those are yes or no because I forgot the squared. So that's second enter. I'm just going to hit it a few times so it goes back to this one. I want to insert my squared here. Oh, and because it's 1, it's still 56 because 1 squared and 1 are the same. So this one is still 56. If we plug in -1, I'm just going to insert a negative everywhere. Oops. And that's negative 90. Actually, even though I plugged in the wrong number, it still worked out that the first one was yes and the second one was no. And then 10, we got 10 cubed minus 17 times 10 squared plus 72 times 10. What does that equal? So replace all those negative ones with tens. And we get 20. And is 20 less than or equal to 0? That answer is, once again, no. All right, so we select or use the yes intervals. So we got back to negative infinity, there's nothing stopping it over here. And up to 0, and then also between 8 and 9. And because we have an equal sign on our inequality, we use brackets, except infinity and negative infinity. It helps I can put in filled circles there, but not very that noticeable. So our answer, we have negative, our interval negative infinity up to 0, union 8 to 9. And 0, 8, and 9 must have brackets. Infinity and negative infinity always get parentheses. All right, so really, like I said, that this one is the hard one. Most of them are set up so you only get 2 numbers here, and it's a little bit shorter. When you get 3 numbers, you just got to plug in an extra one, but solving this takes a little more time as well. This next one here is good to point out because a couple of them will work a little bit different than the rest. You're still doing the same way, it's just what happens when you solve them. All right, so first thing we want to do, we have our inequality, which means we want to get 0 on one side. Right, best way to do that, I'm going to add the 2a and 3. You could subtract the a squared on each side. The reason why I don't is I always prefer to have the leading term. Now we can say the leading term because that's where the highest power is, to be positive. Okay, so we've got a squared plus 2a plus 3 is less than 0. Now we want to set it equal to 0 and solve. So change the inequality to an equal sign. Now, can this be factored? We have just a squared here. We have a 1. Are there 2 numbers that multiply to 3 and add to 2? And that is a no. This cannot be factored. So what we want to do is use the quadratic formula. If you can't factor it, you have to use the quadratic formula. There's no other options for you. So we get a equals, I know we use like a, b, and c for the numbers in the quadratic formula. Hopefully you practice that enough. This is just representing our variable a this time. No big deal. We got negative b. B is 2 plus or minus the square root of 2 squared minus 4 times a, which is 1, times c, which is 3, all over 2 times a, which is 1. And we know what we like to do is simplify the inside of the square root and then go from there. Even though these numbers are kind of small, let's just do it in the calculator real quick. We got 2 squared minus 4 times 1 times 3 is Well, that's a 13, not a 3. -8. Right, and what do we know when we have a negative inside the square root? Is there's an imaginary number. Now here's one important thing. When you make a number line, it only contains real numbers. Since we only solve, when we solve, we get imaginary numbers, that means we put nothing on the number line. This is going to be weird at first. If you have a positive number here, then you would continue because it would be a real number. You would get your 2 answers and mark them off. Since we get an imaginary number here, I make my number line, but I put literally no markings on here. Right. Well, if I put no markings, what does that mean? How do I know what to plug in? When you put no markings on here, you can plug in any number at all. Plug in any one number at all. See if it works. All right, so since we can plug in anything at all, it's, plugging in 0 is always the preferred thing to do, and we can do it this time. And the last time we actually couldn't do it because you can't plug in the numbers that you marked the number line with. All right, so I'm going to plug in a equals 0. I'm going to plug it into where my inequality was, set to 0 on one side. And we get 0 squared plus 2 times 0 plus 3, which simplifies to 3. And is that less than 0? And that is not. 3 is not less than 0. So what that means here is that the whole thing is no, because there's nothing stopping us going left to right. It is D and E, no solutions, because we have no markings. The entire thing is no. Now, if you have a problem like this where you have no markings and you get a yes, then the yes would go for the entire line, and it would be -infinity to infinity. Right, so when you get no markings, it's either D and E or -infinity to infinity. If you do get markings like we did up here, which will be 99, that might be over exaggerating, but 90% of the time, you just do it like this every time. Okay. But that is polynomial inequalities.